question number 5. A stone of mass 50 gram is attached to one end of a string and whirled in a circle of radius 20 centimeter on a smooth table. The stone makes 25 revolutions per minute. We have to sketch the free body diagram, determine the centripetal acceleration, tension, and then the speed of the rotation is gradually increased. The string snaps when it exceeds 0.6 Newton, so we have to calculate the maximum speed when the string snaps and show on the diagram the path of the stone after the string snaps. Okay, for this question, we have the mass, which is equal to 50 gram. Convert that into kilogram, that is 0.123, 0.05 kilogram. And then for this one, okay, so you can either draw the ball to be on your either right or left side, but let's just do it this way lah. Okay, so this is the ball, this is the horizontal motion circle, that is your ball, so the string is there. Okay, so we'll be focusing this way, we'll be focusing. Okay, so the situation ni macam ni lah, begini, macam yang I draw it now. So now let's draw the free body diagram. So it's actually up to you whether you want to put it here ataupun di string di sini. Okay, the ball di sini ataupun di sini. Now we choose this side. So for this one, we will have the weight mg, and then we have the tension. So sekarang ni dia di mana? Dia cakap it is on a table. Okay, so soalan dia cakap on a smooth table. So sekarang ni kita benda ni in contact with the table. Okay, so kiranya this ball is in contact with the table. Macam kamu kasih pusing something on the table. Okay, it's in contact, so dia akan ada satu normal force. Okay, so this is your mg, this is your tension, this is your normal force. Okay, so itu adalah the free body diagram. Next, we have to determine the centripetal acceleration of the stone. So the centripetal acceleration of the stone, which is AC, we can calculate it directly using formula. Kenapa Miss boleh guna directly formula? Sebab sekarang ni dia sudah bagi kita apa? Dia bagi kita 25 revolutions per minute. So 25 revolutions per minute is the omega. Okay, so that is omega 25 revolutions per minute. Just have to times it with 2 pi over 60 supaya kita dapat dia dalam radian per second lah. Okay, next apa lagi dia bagi? Radius, which is 0.2 centimeter, 0.2 meter. Mas sudah saya tulis sana. Okay, so ini adalah the information that we have. So we don't have to solve it using F equal to mac. We can just directly calculate it based on the angular velocity tadi. Okay, so that one is gonna be equal to AC is equal to V square over R ataupun R omega square, kan? So from here we can then use R omega square lah. R tadi is 0.2, omega is 2.6 square. So dari sini kamu akan dapat, let me just double check, okay? Times 2.6 square. Kamu akan dapat 1.35. 1.35 meter per second square. Okay, so dapatlah centripetal acceleration of the stone. Next, we have to calculate the magnitude of tension in the string. Okay, for this case, barulah kita perlu apply force equal to MAC. Okay, centripetal force equal to MAC. Sebab kita perlukan nilai tension, and the only way we can solve for tension is by using this. Okay, so remember, centripetal force is a center-seeking force. Okay, so sekarang ni kalau based on this free body diagram, center kita adalah di sini. So for here, it is gonna be here. This is your center. Okay, so for sign convention, kamu perlu ingat any forces that is pointing towards the center akan positive. Okay, it will be positive. So T sekarang ni akan jadi positive. So T is equal to MAC. Okay, so T is just mass darab dengan centripetal acceleration lah. So M is 0.05 Centripetal acceleration is 1.35. So dapatlah nilai tension to be equal to I have to calculate it back because my decimal point is different than the answer scheme. 0.068 ataupun 675, ikutlah 675 lah. Okay, so dapat tension 0.0675 Newton. So that is the magnitude of tension in the string. Next, soalan dia cakap the speed of rotation of the stone is gradually increased. Okay, so sekarang ni speed of rotation is gradually increased. Omega is increased lah. The string snap when the tension exceeds 0.6 Newton. So sekarang ni bila tension equal to 0.6 Newton, the string itu maximum dia lah kiranya. Maximum. So the maximum tension the string can experience is 0.6 Newton. So dia suruh cari maximum speed. So the maximum speed ni occurs only at t equal to 0.6 Newton. Okay, so macam mana kita cari that value of V? Kita akan apply lagi lah. The total force is equal to mSc. Okay, so sekarang masih lagi T equal to mv square over R lah. Kenapa mesti dia guna AC di sini? Sebab sekarang ni kita mau cari nilai V. Okay, kita perlu cari V. Bukan kita perlu cari T. Kita mau cari V. So, sekarang ni we can just rearrange for V max lah. Okay, so if you rearrange that, you will get T max R over M square root. Okay, so dari sini kamu akan dapat sini aja lah. Kamu akan dapat the maximum velocity to be equal to I'm gonna calculate it again sebab takut decimal point is different. So radius is guna 0.2 divide by 0.05. Dapat 1.55. Okay, so make sure to use 3 significant figures lah bila kamu solve soalan, bila kamu finalize the answer. Okay, so jawapan dia 1.55 meter per second. Next, we have to show on the diagram the path of the stone after the string snaps. Okay, kalau macam ni kita just perlu lukis a circle and then kamu boleh pilih di sini lah. Okay, kita pilih the ball is moving to this side. Okay, so bila the string snaps, when the string snaps, the velocity will be pointing, velocity, it will continue moving to this side. Okay, so this side. So velocity is here, so you can write down the ball, when the string snaps, the ball will continue to move in a straight line. Okay, macam tu saja. So, dia tidak akan continue moving here lah. No, dia tidak akan continue there. It will continue straight ahead. Kalau dia putus di sini pun dia akan straight ahead. And then putus di sini pun dia akan pergi atas juga. Okay, macam itulah. Alright, so that is for question number 5.